Okay, good day once again. So our today's topic I'll be speaking on Pygeo and call it Pygeo. It is a beginner's guide to spatial analysis with Python. So we try to see how we can use Python to carry out spatial analysis. Okay, a little brief about myself. So my name is Wari, and I work as a geospatial data science, a data scientist network. So the organization I work, we work towards building 1 million AI talents in 10 years. So also GIS first, you can't do AI, you can't build talent without data. And GIS spatial data is also part of data used in solving problems. So it's also part of a good mandate that we are here and also try to learn. Okay, now in addition, also I also work as a machine learning engineer. I have interest in data observation. So where I work, we work towards using spatial data, satellite imagery, solving social problems, and also commercial business challenges for different NGOs, and also we also work also for commercial business, those that want to use location intelligence to understand how their market product plays in the market. I'm also a data science mentor. My organization is a learning organization, so I also mentor students on the use of machine learning and data science in solving basic social problems, and also those that want to start a career. With that said, also currently we are also in organization, we are also providing a way whereby students can also learn how to use spatial data with mobility data to solve health issues. So it's one of our hackathons we are also taking part this month. Another thing I also like to talk about is my aspect where I am also a global local guide, star 7. So I like the aspect whereby you go to a location, especially when you know that Google Map is one of the most used map in the world. So when I go to locations and I try to search that locations on map is not available. So I like to map those locations on Google Maps. So someone coming in can have like insight about idea of what that location is about. So it's something I like doing when I'm on transit or in a new place. So I can provide information to other people there. You can get more information about me. That's my website. And also connect with me on LinkedIn. My name is Wari. Okay, start getting started to the agenda of the day. We'll be using Python, show you how to use Python to carry out spatial analysis. So firstly, I will introduce Python and also the basics of Python, efficiency of Python. Then also let's talk about the geospatial ecosystem in Python. How does it look like? And then also we also talk about the different types of Python for spatial analysis. So you see how you can also use things like arrays and also table kind of data. I also talk about vector and raster data manipulation. So vector and raster are the basic data types for spatial data. So we see how we can manipulate those data separately. And also we talk about mapping too. So this mapping tool is going to be an intersections between the vector and the raster data. So while we talk about manipulating the vector data, I'll show you how you can visualize them, basic visualization, and also while we talk about the raster data manipulation, we start to visualize. Then finally, just the conclusion. Also, we'll get started with introduction to Python, getting us to know about what Python is. So Python, so what most people hear about Python, I know it's more like saying which is required. Most of us with GIS knowledge, we're already used to using Python or using GUI tools in solving problems. Majorly using GUI, and most people will argue that arrow is one of the biggest tools for spatial analysis. Well, it's arguable, it's debatable. So Python is an high-level programming language. It's easy to use, very easy to use. So it's not like a low-level programming language whereby you need to understand basic machine learning language where it's going to use. Python is as easy, it's more human readable for you to use. So it's been there for over 30 years. with the introduction when started in 1991. And as that it's evolved from different versions. We had Python 1.0, we had Python 2.0, and currently we are reading Python 3. So at 2020, Python 2 got there because of its issue with backward compatibility with other version of its new innovation. So it's like Python is pretty old, over 30 years. It's like an OG in the computational field. So it's something that's been widely used previously. Another thing is that Python is an open source tool. So you can also use, you can go to Python repo, make contributions. If you see something that you think is missing, you can add yours, and it can also be fixed there. You can use it as anyhow you want to, either commercially or non-commercially. You can use it, it's free. And the funny part is it has about 3,000 plus developers who have contributed. Sorry, 300,000 plus developers who have contributed to Python since the inception. And it has many dependencies. So as at February 2022, there are about 270,000 developers. Sorry, 270,000 dependencies that depends on Python. So just imagine if Python is being paid for or is being taken down. Now many tools are going to be affected, are going to be trashed. So it's free, it's open source. So you can make things, you can tweak things, design, customize how you want. Another tool about Python is popularity. Python is very popular. It's very popular. Very popular. So but let's look at the survey from Stack Overflow. This is a 2022 survey whereby 70,000 developers filled this survey form and talked about the basic tools, the basic tools they use. So you observe, you can also see that on the top 4, you can see Python is top 4. So you see about 48% of developers using Python. And it's a very good result, because if you observe JavaScript, HTML, and CSS, they are web-based, and the world is ruled by the web. So web is the big one. But if you talk about Python, whereby it has more versatility, you can use it anywhere. It topping that chart against Java or C++ is a big deal. Another thing about Python is the aspect that it's multi-purpose. So you can use it in doing many things. You can use it in developing games. It can also be used for data science. This is a very big tool for data science. Like, it's one of the biggest tools when you talk about data science or machine learning. You come to that. So you can also use it as in web, like I said, you can also use it as a backend in web, and you also use it as on-premises server. So with that said about Python, now ask ourselves, why do we use Python for GIS? One question I'll ask is, why not Python for GIS? So Python, with the features I'll talk about, it's like easy and popular. I like simplicity. Like when you want to do problem, when you want to solve problem, you don't need to have thinking of start cracking your head about how you start handling different things. So those of us are used to C++. I have the background is C. You observe that when you're writing SQL, you need to handle many things like pointers, and it's really crazy. So when you come to see Python, see how easy many things are already handled for you. It becomes very easy for you to focus on solving the main problem. Like I said, it's popular. So why it was the fourth popular tool by developers, which I think it's based on human input. These are just 70,000 developers. Yeah, so it might be biased by location, because most of this survey were taken by those in the United States of America. So, but what the data is really saying, what's being said based on popularity, based on questions asked on Stack Overflow, you see it tops the list of questions. So people are asking questions about Python, Stack Overflow, more frequent than other language, even more frequent than JavaScript. So there are more questions about this. So it tops this. So you see from 2018, you see Python have been like the main deal who wants to know how to solve problems in Python, to show you that the usage is good. So why the developer survey is also nice. but I want to follow things that happens based on serendipity, humans actions that was not really tied to particular activity. So I prefer this compared to what the developers say, because this has a more sincere, because I know almost all of us just talk about flow for help. So it proves the point. Apart from popularity, Python can also provide this action of automating things. So you can put everything into a script. So those of us used to QGIS or all the GUI tools, you can see that there are some things you want to do, maybe private analysis in a particular place, and you want to automate that process. Most times it might not be easy for you to do that, although there are also some pre-processing tools in QGIS, like I know, and also on ArcGIS. But Python provides that simplicity in the sense that for all the actions you need to do, just write the code, just one place, just write the code, write the processes, and once everything is running well, you can automate that and repeat that for other places. So it helps you automate boring things that you have used your GUI to do several times. So puts everything in a script and helps you run through that process. That brings me to the action about Python being used to be easily interfaced with other tools. So your most popular GUI tools like ArcGIS and QGIS, so it can also interface with Python. So you have ArcPy for ArcGIS and also PyQGIS for GIS. So those are the most functionalities on these GUI tools. You can automate those processes in Python. So Python can help you do some of these processes. So you can, so you can also, you can even build on top of those GUI tools using Python scripts. And now also I talk about is also its usefulness in remote sensing and also Earth observation. So if you do Earth observation at your core work, you see you can't do Earth observation in this age without talking about deep learning or machine learning. And also one of the biggest tools used for machine learning deep learning is Python. So because it has easily to use libraries that has to do that, like TensorFlow and also PyTorch. So anything that has to be object detection, you're trying to detect or trying to count the number of buildings from the satellite imagery. Then we are trying also to classify different types of drops also from a remote sense image, or you also want to know or segment flood from a remote area. So you also see that machine learning is one of the tools that deep learning is one of the tools that you need to use, and Python is an easy way for you to interface with those tools. So another observation is most machine learning competitions, like what we have in Africa, we have Africa machine learning competition. So most of the learning competition, if you observe, most of them are tied towards Earth observational problem that has to do with agriculture. So, and you observe that if you want to solve problems in those areas that has to be agriculture with locations, you need to be very strong with your machine learning, and Python will help you in doing that. Another tool is also another machine learning platform that also heavy on using GIS to solve the spatial problems with remote sensing is also data driven. So most of the competitions there are on our Earth observation, on satellite images. So for you to be able to get easily into that, you need to have a very strong skill, or you need to know Python, which is easy. You can also use R, but Python, the ecosystem developers everywhere, so it's easy for you to use Python and running them. With that said about Python, we'll move into the ecosystem, geospatial ecosystem in Python. So the ecosystem of Python, you also observe we don't have a lot of ecosystem. We have GeoPandas, we have rasterio, we have NumPy, we have Ledger. So I'll divide this ecosystem into 4 different parts. So the first one has to do with data analysis and preprocessing. So if you observe heavily, most those very, very common to use Python with raster analysis, you hear about GeoPandas, because it's made from pandas. Pandas is one of the biggest library tools used for data science with Python. So you have GeoPandas. Really, you hear of Shapely. Really, you hear unless you really understand the intrinsic design of of the data you want to work with. Your rasterio, that's where you want to work with raster data. You have NumPy. So NumPy is like the building block for almost all of these tools. So rasterio was built on top of NumPy. We have other tools, Fiona, Jada, and raster. So these are all that helps in kind of basic processing, trying to do something like zonal statistics. GeoPandas also do things also like trying to dig a spatial relationship and also try to evaluate different data. Another functionality tool is also database or data source management tool. So I call it database management tool. So these lists are not exhaustive. There are also other tools. I just brought out tools that mostly common and also most people use. So we have Google Earth Engine. Google Earth Engine is more like a platform that allows you provides easy interface to data on spatial easy interface to satellite imagery or remote sensed image. So it's a very, very good tool. So it has a Python interface, although it has a console, but it has a Python interface that allows you to use that. Then we also have PyStack. So PyStack is more of a way, it's a new, PyStack is an interface to Stack. So Stack is more like a new way where that by organization comes together and we have different that came together to standardize the way data, spatial temporal data are being arranged. So it's provide easy interface in such a way that NASA, the way they observe geospatial temporal data, when a developer sees it, he can also easily use it when he also uses data from SpaceX. So it allows it's more like a standardization for spatial temporal data. We also have GeoPython. GeoPython has also helped in managing data. We have rasterio and GeoJSON. Another tool also is machine learning. I had to be the machine learning too because we also use machine learning in solving spatial problems. Yeah. So we also use TensorFlow, which is a big one, PyTorch, OpenCV. You need a very good when you deal with remote sensed imaging. And scikit-learn, which is the father of all machine learning in Python, because without scikit-learn, I don't think you can do any machine learning without scikit-learn. Then we also have data visualization tools. We have Matplotlib, Leaflet, and we have Folium. So Matplotlib, most tools are being built on top of Matplotlib. Most visualizations are built on Matplotlib. Then we can looking at for interactivity, you also see things like Leaflet. So more about this, we talk about more about this when we go to hands-on section. Then moving on, still on the ecosystem of Python. So if you observe, so these are the last downloads from PyP. So PyP is like a hub whereby it hosts Python libraries. So this attracts from the downloads of the different specialties. So if you observe, Shapely is leading. It's very surprising because when I started hearing about spatial data with analysis with Python, firstly, most people were talking about the pandas. Then coming to see Shapely, yes, it's surprising, but it's not really surprising because GeoPandas was built on top of Shapely. So Shapely is like a holding block for GeoPandas. So when you hit GeoPandas to download GeoPandas, when you want to PyP install GeoPandas, you're also hitting Shapely. So Shapely has to be downloaded. So you can also see other tools that have not really downloaded, like rasterio. We have GDAL, and also we have Fiona. So you see that most people using Python for spatial analysis mostly deal heavily on using it for that to be tabular data, vector data, which GeoPandas is a big one. So, okay, more on that. These are another way you look at Python ecosystem, look at dependencies. So you see GeoPandas and you also see Shapely. So you see there's an interdependency between GeoPandas and Shapely. And also you look at a hub whereby GeoPandas is almost feeding to other tools. So there's a very big hub here at GeoPandas. There's also big hub here. There's no big hub at Shapely yet, but since GeoPandas depended on it, it has a peak download rates. And actually also you look at that, those are like the core building blocks of it. You also see tools such as NumPy, you see GDAL, where it also allows you with projection. So the PyTorch was also built on top of GeoDAP. So almost all tools were built on top of GeoDAP, like Fiona and NumPy. I have NumPy. So you see all these big code that are that other tools highly depend on, like pandas, rasterio, and you also see GeoPython is here. Then for the visualization, to you also see things like matplotlib, leaflet. So almost everyone is looking at the matplotlib to interface with. Yeah, so that's that about ecosystem. So I'll just talk about the basic data types in Python. So the basic data type in Python, so we have different data type. Firstly, building block array. So almost no data in Python is not built on array. So array is like one of the basic building blocks in Python. So there are not two also. So one of the things is NumPy. NumPy is like the head through which array is being used or is being built by Python. So it's very, very important. So another thing, we have a table-like form. So this table-like form, when you look at something like GeoPanda, it's not only having spatial data, you must also have attributes of that data. So GeoPandas is a combination of geography and also your number of pandas, pandas table, which have a row and a column. Then we also have a geometries. So geometries, like these are the basics of what spatial data consists of. So we have points, line, line string, multi-point, multi-polygon, and we also have polygons. So these are like the basic building blocks. So these are from a standard for simple features. So almost all your vector data tools are built on top of these building blocks. Then we also have multidimensional array. So it's improvement from array. So why array can be of different dimension, you can have 2D, have 3D, different dimension, but the table can only be of 2D dimension, just rows and columns. And multidimensional data is very important. You use is one of the use case is in images. So you see satellite images is very, very good. Satellite images really depend on multidimensional array. So we'll see more of this when we look at when we go to our demo section. Okay, so with that said, we going to go to our demo section quickly. So I should take you through the demo of how you can create different vector data and also raster data, load, read, and also this very simple analysis on it. So this is the link to there's a notebook. This is the link to a notebook if you want to follow, or you can follow, or you can scan this code if you want to see the notebook directly. Okay, so we'll take it over from here and move to our demo section in Python. Shall we stop sharing my screen now?
Are you done?
Okay. So I'll take you to
Okay.
Sorry, so are you saying anything? Hello, Sunny.
No, sorry.
Okay, so I'm going to my interface. Okay, so can you confirm you can see my screen? I need feedback. Maybe on the chat window, or you can unmute and let me know.
Yes, we can.
See the right screen. Okay, perfect. Okay, so first thing we'll be doing is this. I used a Colab notebook for this section. So Colab it's once you have a Go Colab, you can have access to Colab. So Colab allows you to use run a Python script or Python functions without having to download it on your local PC. So it runs online. So the notebook was shared easily on the previous slide section. So so the first thing you do is downloading of installing our dependencies. So these are the dependencies I'll be using. So these dependencies are highly dependent on GeoPandas. There are some actions I try to perform, and without these dependencies, I could not perform. So you need to install them here. And also this, you also need to install rasterio. So I'm going to run this script now for you to install. So if you observe here, the arrow tree, I had to uninstall arrow tree and install it back because there's a little bug in it in the normal pip install. So I proceed to let the rest install. So while installing also, alternatively to using Google Colab, you can also use other tools like Anaconda or Miniconda. But one very funny thing about GeoPandas is if you install GeoPandas on an existing environment, you tend to have issues with dependency. There's a lot of like conflicting dependency with GeoPandas. So what if you are what is on your local environment? One very important thing for you to do is for you to create a new environment for GeoPandas and also install the dependencies, then install GeoPandas so it doesn't conflict with other dependencies which you already have. So my data, my library has been successfully been imported. So the next thing I will need to do is talking about the building block of vector data. So one of the basic building block of vector data is Shapely. So Shapely is fundamental of vector geometry. It takes from the geometric engine open source. So it's more like a standard different geometry required for spatial data. So it provides also in the interface whereby you can create a geometry and also you can also carry out geometric calculation. So in this use case, I'll take you through different data types of Shapely, which is a building block of spatial data types. The spatial data types, sorry, for vector. So these are importing the library called Shapely.geometry. So Shapely automatically is already installed on Colab. So I don't really have to install it. So I just need to call Shapely. So when I call Shapely.geometry, I call it my two basic geometry. That's the points, the line, and the polygon. Yeah, you can create points like coordinate points where you have your latitude and your longitude. So you can create points using Shapely by specifying the x value, which signifies the latitude, and y value which signifies the longitude. So this is my point 1.4, and also this is my y value 3.5. So once I click on this and print this, it returns a point. So it returns a matplotlib plot object. So when you call point from Shapely, it gives you the geometry or a plot of that value. So now we already have this point. We can also look at the variables it contains. Say if I run this, you see it contains shows a point which is 1.4, 3.5. And when you're creating points, there are different methodology you can use. So you can call the first value, leave a space, and call the second value. That's the x-axis and the y-axis, or you separate them by comma. So these values also follows like a well-known text format whereby you represent spatial data with depth. So whereby you have like points, you just put the x and the y-axis, unlike you present them in more like a geometrical form, like a JSON. This way you can just use normal readable text. So the attributes of Shapely, so you can check the coordinates. So when you call the points.port, it returns a list of each coordinate in that. Now we only have just one coordinate. That's a point, the x value and the y value. So it just returns this list. Then you can also return also attributes of it, like what's the x value. You Sorry, Ibrahim, please can you mute? Okay, so you can also see other attributes like the X value and also like the Y value. So you call the points, the X attribute, what are the longitude, and also the Y value, what are the latitude. Yeah, this latitude. So you see the longitude and latitude 1.43.1. So the next thing you also look at, apart from the point, is the line. So line, like normal lines in your geometry, lines are made up of points which are joined together. So you have different points, and you join them together. So the same way, you can also create lines with like that from Shapely. So you call these are different points. I have points 1, 2, and 3. Yeah. So to create a line, I call the line string, and I put the points, all the points that needs to be in a list in this order. So I call point 1, point 2, point 3, which is enclosed in the list. So on printing this, you see the line here. You see a line here. So these are the line, this is the line. Means which I said it returns the plot of the value. So it is a line. So you can also look at this line in form of like a raw non-text format. So you see this is a line. It shows you this is a line string and also the input. So 1.43.5, those are the first points. The second point follows that same order separated by a space. And the next action 1.47.5 separated by a space. So these are also line strings value. Then you can also look at the attributes. So you can also call the coordinates. That's what's the list of coordinates that line contains using the chords. So you need to pass in that line into a list for you to get those coordinates. So you can see those coordinates are being returned in a list. Unlike the previous, when you print just the line, it brings it out for you in a well-known text. But this other one, it prints it out for you in the list kind of value because you already encapsulate it into a list. So the line coordinate returns are iteratable, pattern iteratable. So most of the time when you want to convert from iteratable to a container, you need to pass it to that particular container you want to convert it to. And as in the line also, you can also find the midpoint on the line. Like if you have the frame line and you see what's the half, what's the midpoint. You can also give it that value. The center point, that's for the centroid of the line. Moving on, we can also see polygon. So polygon also can also be created from different points, consists of different points. So still try to create polygon using the 3 points I created below the list. So I got to call in the object, the class called polygon and 3. Now see the beautiful thing about polygon. So when you call in those different points, at the end of joining the lines in those points, it tries to find where is the midpoint between the last and the first. So these are the polygon bits, but the line does not find a midpoint, the meeting point between the first and the last. So this polygon enclosed space. But now polygons also has what we call an interior and an exterior part of a polygon. So what happens here now is if I try to call the list of polygon here, just what are the coordinates of the polygon, it throws an error because it doesn't know what type of coordinate am I calling. Am I calling internal or am I calling external polygon? So if you can, there are some polygons that are complicated. So when you work with polygons, but you have the outer line of the polygon, I also have like an inner line of that polygon. So it's very important that you understand the type of polygon you are using first. So this throws error. It doesn't know what type of polygon I'm calling. So I need to specify, oh, I want to see the external point of the polygon. So that's when I have to call polygon.exterior coordinates. So on calling this polygon.exterior coordinates, it returns all the points of this polygon in a list like I have specified previously. So this is like we have points 1, 2, and 3. So this returns the value for us in the list. So if you observe one thing, it also adds another point again, means the end point. So it started with 1.43.5 and also 1.43.5, meaning it tries to join the first and the last points together. So it's when it meets at the first point, which forms a polygon. So polygon also, you can also calculate the area of a polygon using polygon area. So polygon area will give you the area for a polygon, which gives you 2.0, which returns in meter, although which returns in meter. So another thing worth exploring, although most time these are the basic building blocks, but when you're dealing with spatial data, you might not see this as just points, lines, polygon. You can see what we call collections of points, and what we call multi-points, multi-lines, and we also see multi-polygons, maybe like an admin boundary, like a multi-polygon. Collections of points, you have like locations of different schools, and also lines, maybe like river bodies. So we'll look more on that when we look at vector manipulation. Moving on, you can also see vector data manipulation. So the vector data, mostly it must have a geometry and also have like attributes, like the data that talks about the geometry of it. So it's very important you have like an attribute as this data points, so you can understand not just the geometry, but when you are saying this is a school, you need to have attribute like what's the name of the school, what's the number of students in that school. So those are like an attribute. And vector data, like I said, is heavily dependent on NumPy, pandas, Fiona, and PyProject. So PyProject helps you in reprojecting your data from one's projections to another projection. So with that, I will show you how we can read vector data. Basic vector data is into pandas, which is like the biggest tools in reading vector data. You have so we call these pandas. We already imported it. You have to import to pandas. We also have to import matplotlib also for plotting. So on doing this, we can also run this. So it imports it, and we also have data. So this data is already on the Google Drive. So this data shows the location of LGAs in Lagos State. So if I run this, I call the file part here, and I also call it. So for you to read the data, I need to use GP, that's the alias for the name of GeoPandas, and also to call also the path to it. So once it runs, you see it loads. Now I can also look at the head of what this data is. So you can see the head of this data. So you can see what this data consists of. You can see there are about 6-7 columns here. About 6-7 columns here. I see the columns name. You have local government name, the LGA name, the time, the different sources. So these are other like metadata attributed to this picture. But now what our concern now is going to be for this to be very similar to pandas data frame, but for it to be a GeoPanda, it must have a geometry that can be referenced. So you have this geometry here. So and this is the geometry. So I can call this geometry on its own here. So the geometry is attributed on the variable. You call the data frame, the GeoPanda data frame, and also you call the geometry. So I'm just trying to read just one of these instances. So let me show you the number of local governments here. So this is the number of local governments. I can read it. Let me just read all of them. It's not much. We have about 19. So there are about 19 local governments here. And you see the first one is placed in Lagos called Agege. So so now I try to read the map of Agege by calling the geometry and also calling Agege. So this data type this returns a multi-polygon data type. Now we talked about polygon, and I also talked about reference to multi-polygon. So it returns a multi-polygon data type. Now for you to get out the geometry like we did in the first one, since it's a multi-polygon, there are different ways for you to get that geometry. So you must call the geoms, that's the particular geometry you want. You want the first part of it and also the exterior part of it, because some geometry can have different exterior parts. So it shows you this. Now, if I change this value now, this is very close. If I change this value to 19, let me change to 19, which references Lagos Island. And I change it to 19. You see the admin boundary of Lagos Island changes. So this geometry, like as an indexing, I can index into different local government units. So if I index to 17, which is Surulere, it shows me locations of Surulere. Moving on, you can also get the area of a geometry. So you can calling the geometry and dot area. It gives you calculate the area for each of them. Now there's a reference, there's a warning here saying the area might be wrong because the CRS value, or where this value was being projected, is projected in a degree format. So it calculates the geometry in a degree-like format. So it might be erroneous in calculation when we use it in meter because we are very used to meter. For those in the US, most people are very used to feet of foot. So I will show you how we can convert this to feet of to meter. So this is the same thing. We call it geometry. It also gives you the area of the geometry. Then you can also plot this value. So you can also plot the geometry for yourself. So you can see the plots. These are what it looks like in Lagos. They can also color it based on the particular local government. So you have the color at different local governments in Nigeria. So you can also access different subsets of the data. So you just need particular local government, maybe Agege, or maybe Lagos Island, or maybe any locations of your choice. So you can, the way you index similar to what index in pandas. So you call data frame, you call it also, you call data frame, then you call also the values inside another data frame that here you find out, you call the local government name and also ask, okay, if the local government equals to Agege, can you give me this value? So it runs this. So this that about polygon. You can also get these are point polygon. So the same way you read where we have our file path and also the path to the file we put it in our data set. You need to also call it. So you see this. If I print out this value, you see this prints out the number of schools in Lagos. You see, we have about 7,900. So this is not like an exhaustive. This is a sample we I got from Q3. You see different schools. So if you look at the geometry, it's a point geometry compared to the one we had previously, which is a multi-point geometry. So this point just single point. With this point geometry, I can also index to the first. If I index to the first, that's one of the points. It shows me one of the points here. I can also for coordinates to see where the points is. So I need to pass it in as a list. So I pass it in as a list. It shows me the points polygon. So these are the points. The x value is 3.3, the y value is 6.6. So I can also check also the CRS value. So if we observe the geographical CRS value is 4326. So which so any calculation it wants to do, you see shows you it represents this calculation in degree for you. You can also change the projection of it. So for example, if you want to calculate the area of it, previously we did area, but it was showing us in latitude. But if you want to do projection of area in meters, you need to convert it to a CLG value of 2039. You can also call the geometry. You can call the geometry. That's area. For the geometry, that's area. So it turns the value for you in meter square. So these are in meter square. So you can convert this to kilometers square by just multiplying all these values by 1000 raised to the power of 2. So if you do this, it converts, by dividing it by, so you convert it from meter square to kilometer square. Since 1 kilometer is 1000 and you want it square. So you see these are the values in kilometer square. So you see like 0.6 has the highest meter coverage, and if you can go up, you can check was attribute is attributed to 0.6. Okay. So you can check what attributes are attributed to 0.6. You can call the data frame here and see it. So you have 0.6 has to do with Ekpe. So Ekpe has the largest landmass in Lagos. Okay, moving on, you can also, this is the point polygon. You can also plot the point polygon and also look at the CRS value like we did previously, which is called 2.6. Now I'm trying to put the point, which is the schools, on top of the local government. So over here at this point, I see specified to increase the size of the map and also change the color to red and marker. That's to reduce the marker. If I have not reduced the marker, you see what happens here. You see it becomes very big. So I have to reduce the marker here. You see it becomes very big. So I need to see those little details. If I do that, it goes by and shows it's in a little bit more shows. So you see the space. I think this is should be the space location of schools in Ekpe. This should be a little show highly dense school. Another thing we can do, we also do is called spatial density. Sorry, is spatial relationship. So we want to look at, okay, what's the number of schools what's the number of schools that are on top of Agege. So this is Agege, like I said, in my first geometry. I want to check what's the number of schools in it. So I need to call the point geometry and I'll also intersect it also with Agege. So it gives me the return point is the data frame that gives me the intersection of this. So if I run this, sorry, I didn't run this previously. If I run this, and I run this, so if we run this, run this, it's a 6. Okay. We can put it on my value. So it shows me there are about 203 schools that are in Agege. So if I run to see, okay, what are the schools there? It just that part in Agege. I can call that geometry that's of Agege as a test polygon of Agege, checking my geometry from the first reference data frame. And I also try to also plot it on top of the intersection geometry. So you can see these Agege and what you see. You can also see the number of schools in it. So another thing also you can do is what we call spatial join. So we know we already had the admin boundary, and I want to add left join on what's I want to add the admin boundary to the schools because my school didn't have local government names. So I also use the left join. So use points and also polygon, then left join and say, okay, once school intersects with the admin boundary, give me the value. So we turn to spatial join. And with that spatial join, I have a column named called spatial join. Column is called spatial join, which shows you the values here. So this spatial join, now if you look at the left of this, so look at the left of this, you can see local government's name, which was not already there in the points polygon. From then also, I can then calculate the number of schools in each local government. So I have to index using value count values, and it shows me the LGA and the number of schools in there. Then, if I have these, I can merge this back to my polygon value that shows me the number of schools in each LGA. Then I can also find a way also to explore this data. So I use to call pandas.explore. So it allows me to explore this data, run this explore. So if you observe, you see there are high more schools in Pygeo, about 146. So you can see also places like it will be also have high more school. The funny thing is that the largest landmass, which is Ekpe, doesn't have more school compared to what we have in Animation, which is a low one area covered. So that's on vector data. So because of our time, I'll quickly rush through the raster data. So the raster data has to do with images. So images are raster data, and all those images are array. So each point of this raster data consists of each point consists of a pixel values, which can also be combined into an array. So I'm using data from Kenya for temperature, dryness. You can also see the features of this by calling meta. You can also see the driver. That is going to be the data type, which is a duty. You see, this is also just a single band, just one band here. It shows you the width and also gives you value of where you have no data in it. You can also see the number of bands here. So this is how you also plot raster data in. So I had to specify this precipitation type and also the CMAP. So the CMAP has to do with what type of mapping or what type of visualization do you want. So I choose a trend node that has to do with green kind of, it has to do with orange kind of like fire kind of. So that's why it shows here. But each of these values also, you can also have to read the separate values because this consists of, like I said, an array which an image consists of array. So you can see the array values in it. Now, it's the majority of them are no data because this is what we specified as no data here. If you observe this no data, no data. Yeah. So another thing also you can also put the histogram of it, like what's the range of values you have. So you can see a range between -0 and -20 and 0, which is like the range of value of where you have the mean dryness in Kenya. So you see, it doesn't take count of the null values, which is very, very smart of it. Then this is also the values, reading the array values also. You can also do basic statistics like the maximum value of that array. You can also do the minimum value. Now, when you do the minimum value, it tends to take in also with the no data. So for you to avoid the no data, you can use max equals to 2. That's for you calculating the mean, don't take incognizance to the max. You can also scale your raster value here also. This also an admin boundary of Kenya, where I'll try to show you how you can also do vector spatial interaction. So here we have, I read the admin boundary of Kenya from here. You can also see the CRS over here. So you can also map the raster and also the admin boundary together. So you calling just, this is you calling the raster value. And on top of it also, you also put the vector value. So this shows you the infinite in Kenya. Another thing I can also do is, you can also do is using our statistics that you calculate what's the mean value for this dryness in each admin value. They use a tool called raster stats. So that's what I help you in doing it. For the inputs, you put the file part to the vector and the file part also to the raster value. So for the statistics, I want to calculate the mean. So when you run this result, it shows you the mean of each of them. This for the 46 about, about 46 admin boundary, admin 2 boundary. So you pass that data back also to the data frame. And once that is done, you can also get, okay, what's the mean value of each of them as a GeoPandas, which you can see that locations like this Garissa has a large mean value. Then it goes on the lower side, has to do with Sambora, and you also have places like Mandera. So that's all we have for this section. Thank you for your